Hello. Now we're going to have a look at the area of rectangles and triangles. We're going to start off by having a look at the formula that we know for them. So the area of a rectangle we know is the length, which we usually give to the longer side, times the width. So it's just length multiplied by width. If we have a rectangle, it couldn't be simpler. We just multiply them together. And we know that our units are going to be squared because we're dealing with an area. We've multiplied a length by a length. For the area of a triangle, our formula is effectively half of that. It's half the base length by the height. But we need to be a little bit careful about the subtlety of what the base and the height mean, and we'll come to that in time. And the way that we write that out more algebraically is half multiplied by base multiplied by height. If we have the letters sitting next to each other, just like length by width, it means they're multiplied. So when we're dealing with letters sitting next to each other, it always means just multiply, and we don't need to put in brackets. When we sub in numbers, we will need to put in brackets, like I've written for the English here. Now, let's get into a few examples and put this into practice. So if I was asked to get the area of this rectangle, well, I recognize I've got the area of a rectangle, so I'm going to write down my formula for the area of a rectangle. So the area for my rectangle is going to be my length by my width. I know that my length is 11 units and my width is going to be 2 units. This is not wildly important which one you pick as being, just that length is often taken as being the longer side. And it's useful to have these conventions so we all mean the same thing. So the area is going to be, now when I sub this in, I'm going to put everything in brackets because brackets with our numbers means multiply. So 11 is our length. So 11 is our length and 2 is our width. So the area is going to be length by width is going to be 22. And because I wasn't given units in this question, I'm going to write down units squared. Whatever units I'm measuring in here, be it meters or centimeters or millimeters or kilometers, I'm going to be doing units squared for my area. Now, our triangle formula, if we wanted to find the area of this triangle, we know we'd write down our formula. The area of our triangle is half the base by the height. Now here's the part we need to be careful of. When we say the base by the height, there's a relationship between the base and the height that is more subtle than is obvious in the rectangle. If we pick 3 as being our base, which we probably would because base often means like on the ground. So the base of a house would be the bit that's on the ground. So the base being 3 means the height would be 2. But it would be mathematically exactly the same if we said that the base was 2 and then the height would be 3. Now I'm highlighting this for a reason. We're going to talk about it more when we come to this more complicated triangle up here. So let's have a look. We write down our area formula and then we say, well, what bits of this do we need to find? Well, I'm going to say that the base is 3 because that makes more visual sense to me at the moment. And I'm going to say that my height is 2. Now I know my formula and I've found all of the stuff for my formula, so I can sub in. It's half multiplied by, when I'm subbing in, I put everything in brackets. 3 for the base, 2 for the height, and I multiply that out and I'm going to get that my area is going to be 3. And again, I wasn't given units, so I'm going to write down units squared. So I was measuring in 3 units for the base, 3 units for the height, then my area is going to be in units squared for an area because I multiplied units by units. Now, hopefully it will be visually fairly intuitive for you that if I had taken 2 as the base and 3 as the height, that I would have ended up with exactly the same number. But here, for this more complicated looking triangle, what's going on here is the triangle I'm actually finding the area of is this one here. If you follow my cursor, it's this one here. The dashed lines are to give us information about the base and the height. So if I was to take 3 as my base, because it's the type of information I'm given in this question, if I take 3 centimeters as my base, then the height up to the furthest point away, to the furthest away vertex from 3, is going to be 4 centimeters. So if this is my base, the perpendicular distance away from that base up to the farthest away point on the triangle is 4 centimeters. So from this base line, I go straight up 4 centimeters, and that is the height that I need to use for my formula. So this is where our triangle formula is a little bit more subtle than it might immediately appear. But I recognize I've got a triangle, so I'm going to write down my formula for that. And then I have to pick my base and my height. So the base must be one of the sides of the triangle, and I've only got one of them, so it has to be 3. So the base is one of the sides of my triangle, and then the height is going to be the distance from this baseline perpendicularly up or at right angles up to the furthest away corner of the triangle, which is 4 centimeters as I'm given it here. So the height is going to be 4 centimeters. Now I've got all my information. Area is equal to a half of, again, everything goes in brackets when I sub it in, half the base by the height, and I'm going to end up with 6 centimeters squared because I'm dealing with an area. Now, here's how we can use our formula for more complicated situations. Here I'm given a rectangle, so I'm going to write down, and I'm talking about the area, so I'm going to write down the area formula. And I know that the area I'm given is 44 meters squared, and I know that this is the shorter side, so I'm going to, as it's given to me in the picture, this is the shorter side, so I'm going to call it the width, is 4 meters. Well, now I ask myself a question. If I know that the width multiplied by the length, or the length multiplied by the width, is 44, and I know that the width is 4, how would I figure out what the missing length was? Well, what number would I multiply, what number here, L, for the length, would I multiply 4 by in order to get to 44? Well, mathematically, I can think about this. If the area is equal to the length multiplied by the width, then the length logically must be the area divided by the width. This is another way of asking the same question as I just asked in English. What number would I multiply 4 by? What number would I multiply 4 by to get to 11? That is the exact same question as asking what number would I get when I take 44 and divide it by 4? So I have 44 and I'm dividing it by 4 and I get 11, and I know that's going to be meters because I'm dealing with a length. So again, in English we would say, what number would I multiply 4 by in order to get 44? And that's mathematically equivalent to saying the length would be equal to 44 divided by 4, and we get 11. Now, if I'm told that this shape here is a square, I should have had that written in for us. So if I'm told that this is a square, what does that tell me? Well, I'm dealing effectively with a rectangle. A rectangle is a type of square. The area is going to be the length multiplied by the width, because a square is a type of rectangle, but it's a special type of rectangle where the length and the width are equal to each other. So I could say this is the length and this is also the length. They're the same length, so we can use the same letter for them. Well, that means that the area is length multiplied by length. But if I multiply something by itself twice, that would be the length squared. So the area of my square is going to be the length squared. So far, so good. Now I know that the area is equal to 81 meters squared. So I know that at L squared, the length squared multiplied by itself must give me 81. And now I ask myself a question. What number multiplied by itself would give me 81? But now when I say that, I think back and I know that that means I'm really looking for the square root of 81, because I know that the square root is the same question. If I get the square root of 81, that's me asking what number multiplied by itself would give me 81. And that's what's going to allow me to find L. L is going to be 9 meters. And we can double check our answer because we know if we multiply 9 by 9, we are going to get 81. Now, if we get a more complex shape here and we're asked for the area of it, there's a few different ways that we could approach this problem. We could take, so we can see a few different ways that we could break this up. We would probably be able to work out the area of this rectangle here. So we could break it up as so. Break it up into that rectangle, this rectangle, this rectangle, and this rectangle. That would be one way to do it. Or another way to do it would be to take the big rectangle and take this smaller rectangle away. And as it happens, I think that's less work. So we're going to try it that way. We're going to take this smaller rectangle here away from the big rectangle that we've got here. But when I want to do that, I see that I'm missing one of the pieces of information. So let's write down what I've got so far. I know that for getting the area, I'm going to want to get the area of the big rectangle. The way I'm approaching this, the area of the big rectangle minus the area of the small rectangle. Well, the area of the small rectangle is very easy. I have the length and the width, but here I don't have the overall length of this side. And that's a bit of a problem because I need it for my formula. So the area of the small one's fine, but I need the area of the big one. So I know this width is 7. What's this length going to be? Well, I know that these are all right angles here. So that means that the overall length from here across to here must be 4 plus 5 plus 2. So this length must be 4 plus 5 plus 2 is 11. So the overall length here must be 11. So that means the area of the big one, dealing with a rectangle, so it's length by width, I'm going to have 11 by 7 is going to give me 77. So that's the area of the big one. And the area of the small one is going to be 4 by 5 is going to be 20. So the area I am looking for is going to be my area big minus my area small is going to be 77 minus 20. You can see I'm telling myself the story of how I'm answering this question as I'm going. It's going to give me 57, and I should write for my final answer units squared. And then finally we want to find the perimeter, and we could add up all of our different sides because that's what our perimeter is. So let's do that. So the perimeter is going to be 4 plus 4 plus 5 plus this side is 4 plus 2 plus 7 plus 11 plus 7. So plus 5 plus 4 plus 2 plus 7 plus 11 plus 7. We add up all of those together and we are going to get 44. And that's units because it's just a length. So that's not units squared because we're just adding up lengths here, so it still remains a length. And that is what we need for being able to work with the area of rectangles and triangles.